Okay, so I'm going to talk in this video about a replicating portfolio for a call option. I'm starting with these slides here from chapter 17, so let's just jump in here. Let's see, we've got obviously exam 2 coming up. I just want to mention here, I always have these questions. Exam 2 works much the same as exam 1. It's only the material since exam 1. So it's not a cumulative exam, it's just since exam 1. I'm going to talk some about delta hedging, talk a little bit about some delta calculations with futures contracts. That's all included in this presentation. Right now in this video I'm going to talk about replicating portfolio with a call option. Now, I've watched Dr. DeFusco's video on this topic and he does an excellent job with this, so I encourage you. These are not terribly complicated problems, but they're not trivial. So if you feel like you need a little extra insight into this, Dr. DeFusco has a very nice video on these delta hedging examples too. So I'll just mention that. That's available to you also. So I'm going to talk a little bit about call. I've got another video where I work through a spreadsheet doing this exact same thing for a put, so you'll have both of those available to you. Here, let me just talk about the call option. Right? So a call option, replicating portfolio. What we're trying to do here, and we're making the assumption here that we're dealing with binomial trees, that we have a certain time frame and a certain time per step, and we know there's only 2 possible outcomes for each step. Right? So based on that assumption, looking at the binomial tree, we start by forming what we call the replicating portfolio. Right? This is one way to determine the price of the option, or to estimate the price of the option. Okay? So we make a replicating portfolio that has exactly the same payoffs as the call option. And a replicating portfolio for a call has 2 parts. You own delta shares, and you have and you borrow a certain amount of money. This B here stands for bond, because finance people tend to think of bonds. It's easier to think about this though as borrowed money, and the B there represents how much money you'd have to pay back from the borrowing that you made initially. Right? So you own delta shares, and you also have a certain amount of borrowing that you do to get money today, and then you pay that off in the future. Okay? So I've got a simple example here of just a 1-period example. You've got a call option here. The current stock price is 50, but it can go up to either 75 or go down to 25 in the next step. I'm assuming the next step is just 1 period and the risk-free rate is 10%, just to make this very easy to follow. Right? The strike price is $50. Right? And you can see what the payoff to the call option would be. If the price goes up, well, if you own the call option, you could buy it for 50 and it's now worth 75, so that's a $25 payoff. If the price goes down to 25, well, you have the right to buy it at 50, but if the price went down to 25, then it's not worth anything to you, so it'd be worth 0. So here's the values of the call option in each future state. You want to come up with a portfolio today that will pay off exactly these amounts, depending on whether the price goes up or down. Okay? And so what we have is we're going to buy delta shares and we're going to have some amount of borrowed funds. And in the upstate, we want this to be true. We own delta shares times $75 per share, and we're going to pay back some money, and that payoff has to be 25. In the downstate, again, we own delta shares times $25 plus pay back some money, and that has to give us a payoff of 0. Right? So we want to solve for delta and B so that these are true. And this is, if you remember algebra from a long time ago, you got 2 equations, 2 unknowns, you can solve this. The way I'm going to solve it is by first subtracting one equation, this equation from the other one. The nice thing about that is the B's will cancel. And so I'm just left with an equation for delta here. So 75 delta minus 25 delta is 50 delta. The B's cancel, and 25 minus 0 is 25. And that says delta is 1/2. So that says the replicating portfolio should start by owning 1/2 shares. Right? And then I have to solve for B, and well, then I can just substitute back into my equation here, knowing that delta is 1/2, and solve either one of these for B. I'll substitute in here, so I know that 25 times 1/2 plus B has to equal 0, so B is equal to minus 12.5. And the minus sign there tells you that you're borrowing money, and you're going to have to pay it back in the future. Okay, so that's how you set that up. You can solve those, right? So, yeah, this says you can replicate the call by owning 1/2 share of the stock and borrowing the present value of 12.5. I should mention that. The B in these formulas stands for the payoff in the future, right? In this case, the amount of money I'd have to pay back in the future. And when you set it up at the beginning, you have to calculate the present value of that. That's an easy step to get mixed up with, and you end up with the wrong answer. So let's make a point there. Right, I'm calculating here the payoffs in the next step. So this value for B has to be the present value that much. I would have to pay back $12.5 at the end. So that means I borrow the present value of that amount today. Okay, and so this tells me that the cost of the call should be the same as the cost of setting up that replicating portfolio. And in this example, we would say the call in this case then costs $13.63636. Okay. All right, so that's just a very simple example of this for one step. And then what we do is we go and make it more complicated by adding additional steps. But in general, that's the idea that we're going through here in these binomial trees and the replicating portfolio. Okay, now I've got an example here. This is Dr. DeFusco's example. He also goes through this. I'm just going to walk you through this here with the slides. I think I may have a little more detail than DeFusco has in his presentation, and hopefully that's helpful to you. But he does a good job with this also. So, either way. But let me go through this. So you have these problems here, and they give you the whole tree, which is kind of nice, actually. They've done a lot of these calculations for you. They give you the whole tree. And they ask you to set up a replicating portfolio, and then notice you've got some of these values are highlighted in yellow, and that's the path they want you to follow. Right? So again, the top value is the value of the share, and then here's the value of the call option at that point. And they want you to set up a replicating portfolio and follow it through this path. So it goes up and then down and then up. And then at the end, they want you to check and make sure that, okay, from here it goes to expiration, and if it, check both states at expiration so that the payoff is the same. The replicating portfolio should pay off exactly the same at expiration that the call option would. Okay, this much if the price ends up at 128, and 0 if it ends up at 100. All right. Now, I've given you the interest rate here, and what I've done is I've calculated the annually compounded rate. So the interest rate is 9% continuously compounded, and it's quarterly compounding. So I've just calculated the, this is the quarterly rate. Right? This is the rate per quarter, 2.2755. Right? So I use that here, but you can just use the e to the RT, if you like, as we go along. Okay, so we're going to follow this path, and we're going to see how the replicating portfolio works. Okay, so we start at the beginning. We set up this replicating portfolio, and we're starting right here. And then we say, well, if we're going to set up the replicating portfolio, we know that we need to have, if it goes up, we need this payoff. If it goes down, we need that payoff. So we're setting up this equation here, right? We're going to own delta shares, and we're going to have to borrow some amount of money that we'll have to pay back B amount at the next step. And that should follow these equations here. This is if the price goes up, and this is if the price goes down. I've got two equations and two unknowns, and I can solve those. And so I'm going through here, and solving those, just doing the algebra. I find that delta is 0.676506, And then if I take that and plug it back into my one of my equations here using that value of delta, I can say that the borrowed amount, I would have to pay back 55.0497 in the next step. Right? So I would borrow the present value of that amount today. Okay, so here's how I would set up the replicating portfolio. I would borrow this amount of money and I would buy that amount of shares. Right. Okay, now, yeah, and we can prove that that will be the appropriate payoffs here. So I say, well, if we go through this and you just say, well, if the price goes up, what's that payoff? And the price goes down, what's that payoff? And you can see that they're the same payoff there. So the replicating portfolio seems correct, right? Okay, now we also have these formulas for delta hedging, and you can use these formulas too to solve for delta. So given that you have this whole tree, only a person who really loves to do algebra would go through and do all of this, which is it's just fine. I encourage you to do the algebra at least once to prove to yourself how this works. But you know, if you have the whole tree given to you here, then you can obviously just use this formula for delta. So to calculate the delta, it's the value of the option in the upstate minus the value in the downstate divided by the price in the upstate minus the price in the downstate. And if you do that calculation here, you'll get the same number for delta that we did doing the algebra. All right, so I mentioned that here. Okay, and in fact, I'm showing you that here. Okay, there's the same delta that we got before. Okay, now also I want to point out here that the way this works is that you know what you'd have to come up with to generate the replicating portfolio, and you can see what the call costs today, so you can observe that today. And there's a cost to setting up the replicating portfolio, all right? And that is you have to buy that number of shares using a certain amount of borrowed money, and the amount of borrowed money you have isn't enough to buy all the shares you need, so you have to add additional funds, right? And the additional funds that you have to add should be the cost of the call. Right, so I've got here borrowing. You can short the call, so we can short the call and get 13.82568, and then borrow the rest to buy the shares. So borrow the rest to buy the shares, and if this doesn't hold true, then the call's not properly priced, and you have an arbitrage opportunity. Right, that's what that's how all of this works. Right, so the cost to generate the replicating portfolio should be the same as the cost of the call. And if it's not, there's an arbitrage opportunity there. Okay, so let me go through here and let's just talk about how we do this from step to step. All right, so we start with the first step and we set up our replicating portfolio, and we have it here. We know we own this many shares and we've borrowed this much money. All right, so we've set up our replicating portfolio to do that. And then you go to the next node, which in this case, the highlight tells us it wants to look at the up state. So we're going to see what happens at the up state. Right now, the price went up, and this is a call. And so we can calculate the new delta there. And the delta will be larger. And that makes sense because since it's a call and the price is going up, the probability that it's going to be exercised is higher. So if you're trying to cover that position, you have to own more shares. Right. So delta will be higher, and there it is. We can calculate delta right there. Notice I'm using the value in the upstate, the value in the downstate, the price in the upstate, price in the downstate, just calculating my delta there. Right. Now, what we do with this replicating portfolio, and I remember the first time I was learning this, it confused me, and I kept getting the wrong answer here. What we do is you set it up at the beginning, and then you do not add any more money to it. I think of it as you set it up at the beginning, and then delta dictates what you do, right? But you only do what delta tells you to do from then on, all right? So at the beginning, I set it up here where I have this many shares, and then I have that much borrowed, All right? But in this case now, at the next step, delta went up, and I now need to own 0.85558 shares. So I need to buy more shares. Okay? And in fact, I need to buy an additional, if you take the difference there, okay, I already own that many shares. I need to own that many. So I need to buy an additional 0.17907 shares. All right? So I'm going to borrow the money to do that. All right? So here's the cost of borrowing those shares, that many additional shares I need to buy, and they each now cost 113.318. So I need an additional 20.29 of borrowing. So I'm going to add that to the amount that I borrowed. So remember last time I borrowed this much. Okay. I'm going to add this much additional borrowing. Okay. Another thing not to forget at this point, it's very easy to do, is remember that this earns interest every step. In this case, I think it's a quarter. Right, so every step you're going to earn interest here, and this borrowing is going to increase by the interest rate plus any amount of additional borrowing that you do. Okay, and I think I have this on the next slide here. Right, I'm going to have to go out and buy that many more shares at a cost of 113.31 per share, so I have to borrow that much additional money. Right, if you take, this has earned interest, and so it's now, what I owe is now 55.04. That's just that borrowing with interest for 1 quarter, and then I borrow that much additional, so I'll have that much borrowing at the end of this step. All right, so at the end of this step, now I've got this delta and that amount of borrowing. All right, and then I'm just going to go through and start with these amounts and go to the next step. So now I go to the next step. Okay, now at this step, the price went down. And since this is a call, the price went down. It is now less likely to be exercised, so delta is going to get smaller. Okay, so I want to own less shares. Right, and we can do the calculation here. Delta is now 0.619974. Well, at the previous note, I'd set up delta 0.855. So I own this many shares. I need to get it down to that many shares. Right, so what I've got here, buying additional, but the number's negative. What I'm really doing is selling off shares to get my delta down. Delta represents the number of shares I own. So I'm going to sell off this many shares, 0.235606. Right, now when I sell off those shares, that's going to generate cash. I'm going to use that cash to pay off my borrowing. All right, I have here additional borrowing, but again, notice that's negative, meaning my borrowing gets smaller, so I'm paying off that much of my loan. Okay. So my delta got smaller. I'm going to sell off some shares. That's going to generate some cash, and that's going to reduce the amount of borrowing that I have. Okay. The main thing here is don't forget the interest rate. Okay, this amount of borrowing earns interest over time, and you have to pay that off. All right, so I'm going to sell those shares. I'm going to generate that much cash. So at the end of step 5, I end up with that many shares, and notice this is I took this number times interest. Okay, that's my net owed here with the interest on that, and then I pay off that much that I generated from selling those shares. So my borrowing at the end of this step now is 53.49. So that's when I end up here. Those are my positions here. And then I'm just going to do this again. All right, I'm going to go up. Notice since I went up, delta's going to get bigger. So I'm going to have to go out and borrow money to buy more shares. Right? Now, once you go up here, what happens is, and this is somewhat of a weird example, once you go up here, then you can think of it as it's now 100% certain that call is going to be exercised. Now, the end here is equal to the strike price, 100. So you could argue that, well, you're kind of indifferent whether you exercise that or not. But you could think of it as, well, that call is going to be exercised, and it's going to end up being, the share is going to be purchased for $100. Right? So that's why delta goes up to 1 in this case. Right? Delta goes up to 1, meaning, hey, we're sure that call is going to be exercised. So if you're short that call and you're covering your position, then you want to own a whole share. Right? So to do that, well, at the end of the last step, I only own 0.61997 shares, so I have to buy an additional 0.3803. that's going to cost me, since the price is 113.31, that's going to cost me that much money, just over $43. I'm going to get that by borrowing. All right? And so at the end of this step, my borrowing will be that amount. What I had borrowing last time, plus interest, plus the additional amount I need to borrow to buy those additional shares. All right? So at the end of this step right here, I own one share, right? My delta is 1, and I've borrowed that much money that I have to pay back. All right, and then the next step's expiration, so we just have to check and make sure that our payoffs are the same at expiration. And I don't have the slide here exactly the way I would like it to be, to tell you the truth. What we're looking at here is what you would have if you had shorted this call at the beginning, right? And so you're short the call here, and then you have gone through this process here. So what I'm saying here is I've shorted the call, and so that call is going to be exercised on me here, and I'm going to sell the thing for $100, and then I'm going to pay back my borrowing, and I'll net out at 0. Right? If you just think of it as, well, I set up this replicating portfolio, you can set it up, said, oh, well, I own one share, it'll be worth 128, and then I'll pay off this, and I'll have a payoff of 28.402. You can do it that way too. All right? But the way I have it in the slide is it assumes you shorted the call to start with, and so you can just give the share for $100. Right? And if it goes down, it's worth $100, or you can think they exercise the call and buy it from you for $100. Either way, you'll end up with $0 there too. Okay? All right, so that is the way you go through the replicating portfolio. Remember, you just go step by step. You set it up at the beginning, and then you're either going to pay off some of your borrowing, or you're going to borrow additional funds, depending on whether your delta gets bigger or smaller, whether you need to buy more shares or you're selling off more shares, right? And just keep track of where you're going here. I have in another video an example with a put that goes through the Excel spreadsheet of doing this, so you can follow that also. And so that's the information there in replicating portfolios for the binomial call option.